Happy Tuesday. We are breaking out of simply solving equations and moving into types of solutions. Up to now, we've been solving an equation and finding one solution that makes the whole statement true. So here we read that most equations we have solved so far only have one solution. However, there are two other special cases, the no solution and the infinite solutions. Solve the equations below to see what happens. So the part I want to point out here is that there's a particular place towards the end where students get confused. So I want to focus on the x, the variable term, as we go through. So let's start. We say there's 3 2x plus 9s, right? So we're having 6x plus 27. That's what this is saying, right? 3 times 2x and 3 times 9 is 6x plus 27 is equal to negative 5 minus 2x. Now at this point, we would simply say combine like terms, move all the x variables to one side and the units to the other, which is what we're going to do. So we want to add 2x to both sides. We're going to get 8x, subtract 27 units to each side. We're going to get negative 32. And so now we know that 8x is equal to negative 32. We're going to take that pile of negative 32 unit tiles, divide it into 8 groups, and we get that x is equal to negative 4. So what does it mean that x is equal to negative 4? Well, it means that if I go back and I'm going to copy over the equation here, putting in that negative 4 for every instance of x. Okay, so now I have 2 times negative 4 is negative 8 plus 9. And negative 2 times negative 4 is positive 8. All right, keep going. Do what's in the parentheses. Negative 8 plus 9 is positive 1. And 3 times 1 is 3. And negative 5 plus 8 is also 3, so 3 is equal to 3. So we know for sure that x is negative 4. That is the one solution that makes that equation true. So let's move on over to the next one. I'll do this in green. So our first step is going to be to do what's in the parentheses, but not because it's parentheses, but because of multiplication. So there's nothing to do in the parentheses, and there are no exponents. The next thing we're going to do is distribute that 4. All right, now we're going to combine like terms, but we're going to keep everything on the same side of the equal sign for now. So we've got 7x minus 3x is 4x. And minus 9, so all the x terms are there together and the unit terms are there together. Here we have a 4x over here plus 13. So this is where I really want you to focus on. We're going to move the x term first, okay? And when I subtract 4x from 4x, I don't end up with 0x. I end up with 0. And that gets the students confused when I first teach this. So think about if x was 1. 4 times 1 is 4, right? And here negative 4 times 1 is negative 4. 4 minus 4 is 0. Not 0x, but 0. So once these are completely 0 and gone, what am I left with? I'm left with negative 9 equals 13. There is no point in adding 9 to both sides to get all the unit tiles on the other side. The point is that negative 9 is not equal to 13, and therefore there is no solution. We lost our x's. So there is no value for x that exists that will ever make that statement true. The final answer is no solution. All right, well, what is infinite solutions? Infinite solutions says that I can put any number in for every one of those x's, and the statement will always be true no matter what number I pick. That means I could pick 0, I could pick negative 32, I could pick 1/2. Whatever number I pick, if I put it in for the same number, so if I picked 1/2, if I put 1/2 in there, 1/2 in there, and 1/2 in there, that I'm going to get a balanced statement and that the left side is going to equal the right side. Well, let's just see if that's true and how that happens. So first, again, we're going to start by distributing. So negative 2 times 3x is negative 6x. Sorry, I thought I was ready to write there. Negative 6x. Negative 2 times negative 5 is plus 10 equals 2x plus 10 minus 8x. So I can do that while I'm at it. Oh, no, I can't because those aren't the like terms. So I'm going to rewrite this side because I've got to combine like terms on the other side. Let's check it out. So I can combine 2x and I can combine negative 8x. And I'm going to miraculously get the same thing. So I have a negative 6x plus 10 and a negative 6x plus 10. And we can see that they're already balanced, right? That means if I put a 1 for x in on the left side and a 1 for x on the other side, they're going to be the same solution to both answers or both problems. How about if I put in a 13 on the left x and a 13 on the right x? Am I still going to get the same answer? Yes, I am. So no matter what number I put in for x, x equals any number. We call it x equals all real numbers or infinite solutions. Well, what's a real number? Well, we don't really discuss real numbers and imaginary numbers here in 8th grade math. Imaginary numbers do exist. And it's not what you think it is. I mean, it kind of is, but kind of isn't. All real numbers just refers to every number you've been taught so far. So if you refer back to when we started irrationals and square roots, we talked about how there are irrational numbers. First we said, oh, there's natural numbers, and then there's whole numbers, and then there were integers, and then there were rational numbers, and then we said over here there's irrational numbers. Remember that? And all of those made the real number system. That means any one of those numbers, including irrational numbers, if you were to put it in for this x on the left, that means you'll also put it in for that x on the right, which means that no matter whether you use a rational or an irrational number, these will always be balanced. Okay? So all real numbers is a way to write this, or just saying infinite solutions. All right, let's go on down and check out the examples below. Let's try an orange. That's a fun color. All right, first thing we're going to do is distribute. Now we're going to add all like terms on the left, which done, and all like terms on the right. And now we can see that 5x minus 3 equals 5x minus 3. So therefore we have an all real numbers solution. If you went the next step further and subtracted 5x from both sides, then you would get 0 and 0. Remember, it's not 0x, it's just 0. Okay, because even x minus x is just nothing. You have an x and you take it away, you have nothing. You don't have 0x, you just have nothing. All right, so that leaves me with negative 3 is equal to negative 3, which means all real numbers or infinite infinite solutions. Now, you may be thinking, Mrs. Evans, do I have to write all that out every time? No. Your counting test wants this. This is what they're looking for, is just say infinite solutions. There's an infinite number of possible solutions. That's all you're saying there. All right, let's look at the next one. There's no distributing to do, and you don't really have to combine like terms. So now, because you're already combined, there's no distribution, the first step is to move the variable terms to one side and the non-variable terms to the other side. And so what we get is a 7n equals negative 42. So you can see here we're going to get a solution. We're going to get that there's only one solution, and that solution is negative 6. Okay? How about the next one? Well, we have to distribute twice. We're going to do 8 and minus 2a equals negative 2a plus 16. So, is this an infinite solutions? Well, if I add 2a to both sides, I'm going to get 8 is equal to 16. And is that true? No, it's not true. 8's not 16. 8 is 8. So therefore, there is no solution. There is no number you could put in for a that would make these balance out. There's definitely no solution here. And last but never least, let's try number 4. So here we have 4 times 2 is 8k. 4 times negative 3 is negative 12. Plus 1 equals 8k minus 11. 8k, if you combine negative 12 and plus 1, you get negative 11 is equal to 8k minus 11. You can see already this is balanced as it is. Any number I put in for k, it'll always be the same number. So therefore, k is infinite solutions. Okay? So at this point, you're going to take your practice worksheet. You're going to go into the Go Formative. You're going to solve a lot of these or not solve a lot of these if there's no solution. You're going to put your answers in, and it will give you the green or red light. You'll know for sure how you're doing. All right, if you're still lost and confused, come find me.